We'll wait a few more minutes for people to join. Uh, I hope I'm audible to everyone. If there's any issues with the audio, please let me know in the chat or something. Okay, I think we can start, and others can join as they go along. I can see around 11 people are here. So, yeah, welcome everybody. Can you all hear me fine? I hope you can all hear me. One second. Yeah, okay, great. Good to know the audio is working properly. Okay. So, yeah, as I was saying, welcome to this week 5 of our lectures. My lighting is a little bad today. Sorry. But yeah, so let me just share the slides of today. I hope you can all see my slides. So, yeah, welcome to week 5 of this problem solving sessions for the NPTEL course Joy of Computing Using Python. So, let me just open the chat on the side. Otherwise, or let me just take my phone. Give me a second. I'll take my phone so I can look at the chat. Okay. So, as I was saying, welcome to week 5. So, these are these problem solving sessions. By now, you should know that we have these problem solving sessions. I am one of the TAs, but there are also other two TAs who are taking these sessions, live sessions, so that you can interact with us and clear your doubts. And we'll also solve some sample programs and assignment questions so that when you do the actual assignment questions and programs, it's a little easier for you. As always, my name is Zenia, and I'm an astrophysicist at IISc, and this is my email ID, and this is the website where I maintain all the links. That is the recorded videos and the slides of these sessions. I'll share the link towards the end of the class in the chat, but I think otherwise also you are getting all the links from the NPTEL team as well. So yeah, that's all about the course. You know that this week we are going to be focusing on the week 5 lectures. So week 5 lectures, you saw an introduction to dictionaries. So there was this, I think, Google Translate kind of, or something that mimicked Google Translate kind of program. Apart from that, you saw different ways in which you can sort and search an array. And that's very important because you can find that, as I've been saying from the beginning, programming is a sphere where you have a lot of uh, place for creativity, right? So if you look at sorting itself, you'll see that a simple sort of an array from ascending in ascending order itself has many different ways to do it. And some ways are more efficient than others, and that's something that you have to think about as you learn programming in higher and higher levels, is that there is always efficiency to how I write my code. So I think I have used this example several times already, but for example, if I want to print the numbers from 1 to 100, I can of course sit and write 100 print statements, print 1, print 2, print 3, but that's like a very bad code and it's a waste of time also, right? Instead, if I write a small for loop, the job can be finished in matter of couple of lines, right? Maybe one or two lines it can finish off. So the idea behind coding is not just to get the task done, but to get the task done in a creative way. There should be some reason to why we are going to the computer, right? There should be some reason as to why we employ the computer. If I am going to write 100 print statements, I might as well have taken a pen and paper and written it myself. Whereas if I write a for statement, tomorrow if I have to print the number from 1 to million, then I just have to change the condition in the for loop to million, right? I don't have to sit and write whatever 999,000 more print statements for that. So that's a way. I think sorting algorithms are a way in which we can really understand the question of efficiency and all those things. And again, when you deal with large amount of data or more complicated programs, then if something taking 1.1 second as opposed to 1 second itself can make a difference. Like 1.1 second, a 0.1 second more may not seem like a big deal, but then when you're doing that thing 1,000 times, that adds up, right? Adds up to a big number. So these are the things that you have to think about when you're coding. Of course, there are other good coding practices that I've been showing in every class so far. And yeah, basically these are also that you become not only a good programmer, but some programmer whose programs are understandable by you and also by others. So we have already looked at what are lists. And to some extent, I guess you guys are also seen what's tuples. I didn't include it explicitly here. Dictionaries are another way in which we can store data in Python. So we have seen integers, strings, lists, and now we are seeing dictionaries. So dictionaries store values in pairs. So you can see that there is a key value pair. So here a dictionary is a collection which is ordered, changeable, and does not allow duplicates. So this is very interesting. You can see that there's an asterisk near ordered because as of Python version 3.7, dictionaries are ordered, but in the previous versions, dictionaries were unordered actually. So this is because they're recognizable by their key. I guess the order was not needed, but I think as per the latest version of Python, I think we are at 3.11, 3.11 or 3.12 now, I forget. But yeah, the most recent versions do have some ordering in the dictionary as well. So this is another important aspect is that there are many different versions of Python, and Python itself has Python 2 and Python 3, and I think most of you must be using Python 3. But even Python 3 has different versions, right? 3.1, 2, 3, etc. I think again now we are maybe at 3.11 or 12 or maybe even higher than that. So we should always be careful if something has changed in Python. So usually between the different versions, there will not be any drastic changes. Like suddenly for loop will not stop working. You don't have to worry about things like that. If someone muted my microphone, please don't do that. It's very irritating, okay? If you did it by mistake, it's okay, but please don't do it again. Okay, I hope I'm audible. If at all at any point I'm not audible, please interrupt me or put it in the chat. Is there a question? Any questions? Okay. Hello, is there a question? Okay, okay, I think by mistake. Okay, anyway, so yeah, so here you can see that as I was saying, you have to be careful about which version of Python you're using. Sometimes small things can change. So again, functions themselves don't really change that much. All the standard stuff does not change, but sometimes small changes can happen. So it's a good idea to always, and like last week I told you about looking at documentation, right? For NumPy, for other libraries, for every module in Python, you can find its own documentation page. So you should always look at the each library also has a version. Like there is a NumPy version, there is a Pandas version, there is a DateTime version. So you have to check which module or which library you have installed in your system, either through Anaconda or some other way, and check for the documentation of that particular version. Okay. So these are just small things that will come naturally when you do programming, but I'm just mentioning it specially so that you can keep it in mind. So this is, for example, how you can define a dictionary. So there is this inbuilt function you can called dict, and you can see here that name, age, and country are the keys, and John 36 and Norway are the values. So if you print this, you will find that. So let's see how this looks like when we actually run this code. So I'll just open my terminal. Sorry. uh, what is the issue? Okay. I think there should not be any spaces. Now will it work? Okay. So yeah, sorry about that. I didn't know that there should not be any spaces. So let's do it again without the spaces. This is this part of programming. Sometimes you'll run the correct command, but Python has some rules like there should not be any spaces or something, and that can interfere. Okay, so this, and if I now print this dictionary, so you can see that there's a key and then there's a value, key value pair. So name John, age 36, country Norway. I can add more entries to this dictionary. Either I can add a second person, or I can add something more like, address, like street name or something like that as well. So, or gender or something like that. So you can always add more key value thing, but you can't add duplicates. That's the point. Okay. So, yeah, so you can't add another person, sorry. You can add more characteristics. Okay, so that's about dictionaries, just so you are all clear. Okay, so this is just a way in which we can store data. Similar to lists, there's now dictionaries. Okay, so now we can look at sorting, and I think you have seen a lot. You have seen bubble sort, and I don't know if you have seen selection and insertion sort, but I thought that we can discuss very quickly three different sorting algorithms and how sorting can be done. So when I say sorting here, what I actually mean is you have an array of numbers and you want to arrange that array in ascending or descending order, right? So all the examples I'm showing will be ascending order, but of course, if you change the condition from less than to greater than or whatever it is, you can make it into a program for descending order. And I encourage you, I'll be sharing you the programs for ascending order. I encourage you to try to sit and write descending order program from scratch. It will be a very good practice for you. It will also help you to understand the algorithm. Sorry. As I said before, like until you sit and write the programs or do the coding yourself, it can be very difficult. It will be as if I'm telling you some story and you're just listening. So I will share with you the programs as usual. As every week I share with you all the programs that we discuss, so you can find in the Google Drive, all the programs will be shared. So I'm telling you that these will be the ascending order program, that is from smallest to largest it will sort. So you try to write the program such that it sorts from largest to smallest for all three of these methods. Okay. Okay, good. So I hope there are no questions. I'm just moving forward. So, okay, so the first sort is the simplest case, which is called bubble sort. So this picture kind of explains the whole thing. In bubble sort, essentially you compare element with the next element, an element with the immediately next element, and you keep comparing like this. And the reason it's called bubble sort is because at the end of it, after swapping and doing everything, the largest element kind of bubbles to the top. So you can see that here, for example, the actual order should be 3, 4, 5, 6, 8, right? So here you can see that first 5 and 3 are compared, and you are seeing that 5 is not in the correct position because 5 is actually larger than 3. So they both are swapped. Then the next two elements are compared. That is 5 in its new position is compared with 8. Now 5 and 8, when you compare, you're seeing that it is actually in the correct position. So no need to swap it. Now when you compare 8 and 4, you will find that again 4 is in the wrong position. So 4 should be swapped and 8 should come first. Then again you compare with 8 and 6 and you see that again 8 is in the wrong position. So you swap them both and finally 8 comes to the top. But you can see that the array is still not sorted, right? 4 should be here and 5 should be there. So what happens is this is just one of the iterations. You have to keep on repeating it until you see that no more swaps are required. So in the second iteration, for example, you will compare 3 and 5, you will not swap. You will compare 4 and 5, 5 and 4, and then you will swap. Then you will again continue on. So you have to keep doing this entire process and keep going through the array until there is no more swaps that is possible, or there is no more swaps which is required. So that's why it's called bubble sort, because at every iteration or at every pass through the array, the largest element kind of bubbles to the top. So this is the idea behind bubble sort. So I can show you the program also. I think you guys can understand better that way. Is there any questions in bubble sort before I go to the program? Do you all understand the idea behind it? I keep comparing elements which are adjacent elements, and I keep swapping until the biggest element goes to the end. Then I compare the remaining elements, and then the next biggest element goes to the end, and so on and so forth. So suppose this was completely in descending order, then I have to take every element and move it to the end, right? So it will take a lot of things. So okay. So no ma'am, no questions. Very good. So I'll just show you the program. So this is basically bubble sort. This is the function which does bubble sort of array. So here this is a for loop which goes through all the elements in the array. You can see that for I in range of n is basically the length of your array. Okay, I'll just make it bigger. I think you can all see the program, right? Is there any problem? Yeah, I hope you can all see the program. So you can see that n is the length of the array. So this is, I can write it here in this. So you first go through the entire array. So you take the first element, then you're comparing with the rest of the elements, right? So range of the array now is from 0 to n minus I minus 1. You swap the element if the edge. So here you're taking n and then you're taking the next element, and from that you're doing it, okay? Suppose this is 0, then first 0 will be compared with the next element. So for suppose, yeah, first we go from, okay, yeah, sorry. So this goes through the entire array, but this is for each of the elements. So here you can see that first you consider 0, you consider 0 and 1, and then if 0 and 1 is too much, is in the wrong direction, so here it's greater than, because we want to finally do it in the ascending order. So if j is greater than j plus 1, that's wrong. We need j always to be less than j plus 1. The smaller element should come first and then the bigger element, right? So then you are swapping. So this is how the swapping is done. This is a single line swapping. But if you want to understand how swapping is done in other ways, please go back to the first lecture or the problem solving week 1 of my class. In that, I have actually given you a few different ways in which you can swap elements using temporary variable and other things. So this is a very nice thing in Python, that you can just write it like this and it actually swaps. But some other languages, they don't support it, and you have to use something called a temporary variable. So that program is there in my not week 1, week 2 lectures. Please go back, and the code will also be there in your uh, Google Drive. Okay. So here, if I now run this program, you can see that when I run it with this example 2, 1, 10, 23, it gives me back sorted array is 1, 2, 10, 23. So it would have compared 2 and 1 first, then it found that 1 is smaller, it has to swap. Then it compares 2 and 10, no swap. 10 and 23, no swap. Then again it goes through once and it finds there are no swaps, so it was easily able to give us the answer. Okay. So this is bubble sort. Is there any doubts in bubble sort? I think it's easy to understand, right? We are just comparing element by element. Okay.
Excuse me, ma'am. Can you show me that program once again?
Yeah, sure.
Just for a second.
Can you see the program?
I have been a little bit confusion on that. This is the if a r minus j plus 1 is there, na? You said that the j minus 1 it has to come. Then I'm getting confusion.
No. Oh, okay. So it can be j and j plus 1 or j minus 1 and j. It can be either way. Basically, you want to compare two elements which are next to each other. So you can write it in either way.
Either? Okay.
Like if it's basically I might have spoken wrongly. It should be basically see, if I have an array, say this is j, suppose this is j, then this is j minus 1, this is j plus 1, right? Either I can compare j minus 1 and j, or I can compare j and j plus 1. Both are okay. Okay, when you write the program, if you take this as j, then this will be j plus 1. If you take this as j, this will be j minus 1. So it just depends on how you start the program. So if you write it as j minus 1, then you shouldn't start from the first element, because if you go to j minus 1, there is no element here. So then you have to start the program from the index 1, not 0. Do you understand?
Yes, ma'am. Yeah. Thank you.
So it's just it's just a matter of what you prefer to do, if you want to start from that or this. Bottom line is, I have to compare the adjacent elements. So that is my idea. So here you can see that I am only going to n minus I minus 1 because I should not consider the very last element because there is no j plus 1 to compare, right? That is the idea. Like if I reach here, I should not be comparing with the next element. There is no next element. That's why there's a minus 1. Whereas if you write the code in a way that you're comparing j and j minus 1, this will become 1 and this will become n minus I. So that's the idea. Okay. Any other questions? I hope this is clear. So this is one of the algorithms, this is bubble sort. You can think of bubble sort is the simplest algorithm, but it is also somewhat inefficient because if you think about it, every time I am comparing two elements, right? And finally, I have to again go through, even if it is sorted, I have to once go through the entire array. Then only I know that it is, I have to keep checking for swaps again and again. Then only I know if it is truly sorted or not. So bubble sort is like the simplest and little bit inefficient algorithm, and there are more efficient algorithms which have been done afterwards. Okay. So next algorithm is selection sort. So in selection sort, the idea is that you always select the minimum value and place it at the first index. So here you can see that the different iterations, again you have 20, 12, 10, 5, 2. Again, all my examples, I'm telling again, all my examples are for, oh, actually this is the for, no, it's correct. It's correct. Sorry. I got confused. I thought it's for the minimum value. Huh. So, what was I going to say? I forgot. Yeah, all my examples are for ascending order sorting. I encourage all of you, you have the programs, but try to write descending order programs from scratch. That will be really useful for you, and you will really understand the difference between these algorithms because they all seem the same because they are all doing the same thing, right? Arranging an array, but they all do it in slightly different ways. To understand that, you should actually sit and write the algorithm, then you can understand it better. So in selection sort, as I said, you select the least value every time, the minimum value of the array, and you try to place it. You go through the array and you find out which is the minimum value and then place it in the beginning. Then you see which is the next minimum value, and so on. So you are not actually swapping at every turn. You are just trying to identify the minimum value. We have already seen how to find the minimum and maximum value of an array. In fact, there are also built-in methods to do it, but you also know how to do it without built-in methods, right? So what you have to do is you have to go through the array n minus 1 times, because if the array is n long, then first you'll find the first smallest element, then you'll find the second smallest element, then the third, and so on. Okay, so this is how selection sort works. Okay, so now I will show you the program. Sorry, there's so many things open. I'll just close all this. We'll need this only later. Okay, so you can see this is my selection sort algorithm. So here you can see that I am passing in array and the size as the parameters to the function. So for s in the range size of the array, you can also do it like we did it the previous program where we didn't accept this array. I mean, we didn't take the size as a parameter. We just calculated it within the function. Again, there is no, this is not the algorithm for bubble. Sorry, this is not the program for bubble sort. As I said to, the doubt before, there are always small changes you have to do. But the idea, the algorithm should be the same, that you're comparing array elements with each other at every turn or whatever it is. So anyway, so here you have taking array and size as input parameters. Then uh, first you assume that the minimum element is at the first position 0. Then you compare with all the other elements, and if any of the other elements are smallest, then you basically take the minimum as this. Okay, then you have to arrange the minimum at the correct position. So again, you have to take the minimum to be the first element, and then the second time it will be in the second position, third smallest will be at third position, and so on. So now if I for descending order, you have to do it in a different way. I don't know why it's written here like that. So now you can understand. Now if I run this for this array 7216, you can see that the sorted array in ascending order is 1, 2, 6, 7. So again, in the first pass, you're kind of trying to identify the first smallest element and putting it in the first position. Then the second time, you're trying to find the second smallest element, putting it at the second position, and so on until you reach the end of the array. Okay, so this is selection sort. Does everyone understand selection sort? Is there any doubts in this selection sort algorithm? Check the chat. So this is the program in case you guys want to see. Okay, I think there are no doubts. If there are doubts, please stop me. Okay, I know this can seem simple, but actually, if you have any doubts, please stop me. Okay. Uh, so the last program that we have is insertion sort. Okay, so insertion sort is basically you always maintain a sub array or a smaller array within your array which is sorted completely, and then you grow that sub array to be the size of the full array. So here you can see that I have this array 23 1 10 5 2. Again, this is for the ascending order sorting. If you want to do descending order, then you have to do it in a different way, and that's why I'm telling you that try to do that. So here it's called insertion sort because it takes each element and inserts it at the correct position. So here you can see that we start with 23 and then we look at 1, and we know that 1 is definitely smaller than 23, so I have to insert it here. Then I look at 10. Now 10 is smaller than 23, but it is larger than 1. So I should insert it between them both. Similarly, 5. 5 is smaller than 23 and 10, but it is larger than 1, so I should insert it here. Similarly, 2 should be inserted in the correct position, and that's how you get the fully sorted array. So this is insertion sort and how the idea behind insertion sort. Which is better to use, selection sort or bubble sort? I think selection sort is slightly better. We can look it up after this. I forgot actually. I remember studying all this long time ago. So let's just we can look at the complexity and which is better at the end of after I mention insertion sort also. Okay, let's look at it together. That's a very good question. And as I said, efficiency is very important. It's a very good question that you asked. So let me just show you the program for insertion sort. So here, this is the function for the insertion sort. It accepts some list or array or whatever it is. So here you have the outer loop, which looks at going through the list. And then what you're actually doing is moving the elements of list 1 from 0 to I minus 1, either of which are greater to one position ahead of their current position. And you're looking for whenever it is greater than it and less than the next element. So you want to insert it at the correct position, right? That's what's happening. So you're moving it ahead one by one and seeing if it is the correct position. So then you find finally which is the correct position and put the element exactly in that position. So this is how it works. If I now run the code, you can see that this is the unsorted list and this is the sorted new list. So 7216, it is sorted as 1267. So again, let's look at what is actually happening. We go through the entire list from the first element, because obviously we don't have anything to compare the zeroth element to. So we actually go to the second element, which has index 1. Then we call the we take the first element and we compare it with the previous element, right, the zeroth position. And if the zeroth position is while the zeroth position is greater than 0, so that is just to ensure that this index doesn't become negative, and a is less than list 1 of j. Basically, if you find any element which is small, if you find that this element is smaller than any of the jth elements, then place it in the exact correct position by placing it like this. Okay, then you reduce j and you go back to the beginning of the array. So you keep on going back in the array and check if, so here for example, when I consider 10, I first go one step back and I compare with 23 and I see that yeah, it is actually here. Then I have to again compare with 1, right? So the difference between bubble sort and this is that in bubble sort, after comparing 10 with 23 itself, I would have done this swapping, right? Whereas here, instead of swapping, I first check with 23 and I check with 1 also. And then whichever is the correct position, I only place it there. So there is no swapping involved. So that's how it works. And finally, you call list 1 as A, and that's how you do it. Okay. So is there any questions in insert sort at all? Yeah, someone says selection sort is better. That was also my guess, because in bubble sort, if you think about it, every time you have to do, continuous swapping. So you have to compare, then swap, then again compare and swap. Whereas in selection sort, you go through the full array, you find the minimum element, then again go through the full array, find the minimum element. So you're not continuously comparing and swapping. So in that way, selection sort is slightly better. But we can also see that, sorry, okay. Sorry, comparison between bubble sort, insertion sort, and selection sort. So I think bubble and selection are kind of having the same time complexity, and even insertion sort is having. So bubble and selection have the same worst time scenario, while insertion sort is slightly better. And best time case for insertion sort is order of n, which is not possible for bubble and selection. So here they have given some of the ideas and disadvantages and advantages of this. So you guys can look into all this advantages, disadvantages. Maybe I'll just put this in the thing. So yeah, it's not as simple. So always when you compare the algorithms, you have to take the worst case scenario. So for an ascending order, the worst case scenario is if the array is fully in a descending order, right? Then bubble sort would have to swap everything. Similarly, selection sort also has to compare and find the minimum every time it will be in the last position, and you have to take it all the way back. So and so on. So that is the idea behind checking the complexity. So that's something that you guys can check, and it's a very interesting question that you have raised right now. Okay. So yeah, these are the things that you have to think about when you design an algorithm for a purpose, right? Again, as I said, designing an algorithm for printing something 100 times, if I sit and I say the algorithm is to write print 100 print statements, that's a rubbish algorithm and people will laugh in my face. So like that, when I'm doing sorting also, I should find a very efficient algorithm to do the same. This is the idea. Okay. Is there any other doubts in sorting? Okay, so I see that the answer is no. If there's any other questions, please put it in the chat. We can see, look at it also. But for now, I have just put in the comparison also here so that you later, when you guys have the slides, you can take the link and go and see it. So let's do some questions. So as usual, I'll show the question, and I want you guys to answer A, B, C, or D in the chat. So please do the same. Okay. So, yeah, so let me just give the first question. So first question is based on Monty Hall problem, which I think you would have discussed in the class already. You have discussed, right? Monty Hall. It's a very famous problem in probability. Did you guys discuss or not? Just yes or no? Yeah, okay, good. Thanks. So yeah, so this is the first question, which is, imagine the Monty Hall problem. So the typical Monty Hall problem is you have three doors, and one of the doors has a great prize, the other has two goats, and one of the doors is revealed to you. So is it better to swap your answer, or is it better to keep the one that you have? So here this is the Monty Hall problem with four. Sorry, I showed the answer. Four doors instead of three, and Monty has opened one door to reveal a goat after your initial choice. So one door is open. What would be the probability of winning the car by switching? So please try it out. This is more of probability than coding, but yeah, I'm just showing you the last year's problems, whichever were there. I'll give you a few minutes to work it out. Okay, someone says 1/3. Well, the question is for 4 doors. So it's not your typical Monty Hall problem, it's little modified. Any other answers in the chat? Okay, someone says C. Others? Okay, okay. They're not getting updated on my phone again for some reason. Okay, C, D, A. I can see different answers. B. Okay. So, yeah, I think A, B, C, D is fully covered by the option. So someone says D always be more than half by swapping. Okay. Okay, maybe I'll give 1 more minute in case someone else wants to try their hand because we don't have a majority answer yet. So if someone wants to contribute to a majority answer, please go ahead. Okay, maybe I'll go to the answer. Uh, so the answer is actually okay. The answer is actually D. And I found, see, I'm also not a mathematician, so I found a, where did it go? Huh, I had a, oh, okay. Just give me a second. I had found a stack exchange answer that explained this. But yeah, the idea is basically what one of them said, one of you guys said, which is the probability is always more by swapping. Okay, so that is why it's 3/4 because it's always more. But I found a very nice stack exchange answer that explained this also. Just give me a second, okay, very quickly. I'll just look it up. I thought I'd put it in the slides, but I guess I forgot. Sorry about that. I'll just 4 door hall. Hmm, where did I go yesterday? Okay. Sorry guys, I can't find the exact when you where you pick one by one. Okay, I can't find the answer I found yesterday. I don't know why. Let me just share it with you later. But yeah, the essence of it is I'll find it and put it in the slides later. I don't know, it's not coming up in my history, but the essence is what one of your friends said, which is that you will get a more than half probability of winning by switching because already one of the goats is out of the equation. That means you have only three options left, and then that's how you kind of go through the idea. Okay, so that's the idea. I'll find the link which nicely explained it and also put it in the slides. I thought I had already put it, and now suddenly on the spot, I'm not able to find it. Sorry about that. Okay, I think we can go to the next question, unless anyone has anything more to add to this Monty Hall problem. Okay, I don't see anyone saying anything. So then this is the next question. Yeah, what happens when you try to add a new key value pair to a dictionary using a key that already exists in the dictionary? So I already discussed this a little bit when I discussed dictionaries. So please put your answers in the chat. Yes, immediately people are saying A. Okay, A. Others? I see three people saying A so far. Others? I give 1 more minute to answer. There's nothing to work out here, so you should be answering immediately. Anyone else? Okay, one more A. Okay, yeah, good. All of you answered quickly and all of you answered correctly also. If you try to add a new key value pair to a dictionary using a key that already exists in the dictionary, you will override. So when I said previously, I had mistakenly said that you can add one more, you can't, right? If I, before we had run, right, John, Norway, whatever, if I add some other name, then that will completely override John. Okay, good. Everyone knows their dictionaries well. Okay. So this question is a little long. So I'll try to explain it and then we will go to the question. Okay. So this is about the TV. This is from question based on the TV show Big Bang Theory. So do any of you watch the Big Bang Theory? Okay, good. You can see one person has raised their hand. Nice. So others, it doesn't have, you don't have to watch the show to understand the questions. It's fine. So essentially in the Big Bang Theory show there was this extended version of rock paper scissors where two extra options were added, which are Lizard and Spock is a character from Star Trek. So here you can see that now instead of just having the three options, which is rock wins against scissors, scissors wins against paper, paper wins against rock, which we usually play, there is also some additional options which is based on Lizard and Spock. So rock wins against Lizard, Lizard wins against Spock, Spock defeats scissors, etc., etc. So there is a whole bunch of new, like there are 1, 2, 3, 4, 5, 6, 7 more options, right? So each option can defeat two other options, lose to two other options, and draw with one other option. So this is how it works. Okay, so you already saw how to code rock paper scissors game, right? You have to assign value to the choices. So you, for example, you assign 1 to rock, 2 to paper, 3 to scissors. Then you get the input from the user. That is whether the user is choosing to play 1, 2, or 3, and then you have to use a secret bit position and code the rules so that based on the bit and the input of the user, you kind of compare with if else conditions and then you declare the winner. So then you can run the program with different inputs and that gives you the output. So this is something you have already seen in the class. Now the question is that which are the steps we need to change in order to run rock, paper, scissors, lizard, Spock. Okay, so again, these are the steps. I don't know how to show you both. So you're basically assigning value, inputting user choices, secret bit positions, coding the rules, and running the program. These are the 5 steps. So which are the different ways in which we have to change the program? So you guys please put your answers in the chat. I hope you understood the question. Now we are changing rock, paper, scissors to this different version. What you need to understand is now we have 5 options. Okay, A and B, someone says. Others? A, B, okay, nice. Other question, others. I only see two people who have answered in the chat. If you want to see the question again or the previous slide again or something, please let me know. Okay, someone says D. Any other answers? Or should we go to the answer? Sorry, any other answers in the chat, or we can go to the actual answer? Okay, I think we can go to the answer. Others, please answer in the chat. It'll be good if it's more interactive. That's why these are live sessions. Shouldn't be like you're watching the videos which are already recorded, right? This is an opportunity for you to interact. So yeah, the answer is all of the above, but it doesn't really make sense because none of the above is also an option. So basically the answer is A and B. So all of you are right. So I basically solved these questions from the last year NPTEL assignments and programs. So sometimes I guess they have some weird options. I don't know why it's like that. But yeah, those of you who said A and B, those of you who said D, all of you are right. Okay. I don't know why none of the above and all of the above are included. I don't know why that's like that. But yeah, basically now the important thing is the concept, which is that now we need to have five options, and we also the positions, the algorithm which use the positions actually needs a bitwise operations to happen with modulo 5 instead of modulo 3 like you did in the class. That's because this is based on a base 5 kind of thing, right? Oh, sorry. So next question is should be also you should answer immediately because we just spoke about this in quite some detail, which is that how does bubble sort compare elements in an array? Please, all of you put your answers in the chat. Okay. Immediately two people say A. Others? Everyone should answer this because I just explained this in a lot of detail. I only see three people answering. Oh, okay, no. There are more people, yeah. Okay, five of you. I'll just wait one more minute in case someone is still answering. Okay, I think, yeah, okay. Okay, good. So I think the answer is clear to everyone. I don't think this requires any explanation. We already explained what bubble sort does and how it compares. So it does the adjacent elements, and every time it has to compare pairs of elements and swap them if they are in the wrong order. Okay, so when sorting a list in ascending order, when does bubble sort show poor performance? So again, read the question carefully. When sorting a list in ascending order, when does sort show exhibit poor performance? Please put your answers in the chat. Okay, I see a lot of people saying B, but also some people are saying C. Also, one person says B. Does bubble sort always show poor performance? Depends on what you define as poor performance, I guess. But yeah, uh, I'll give one more minute in case someone is answering. Yeah, but in so okay, time complexity may is always defined based on the worst case scenario. Number one, and number two is that there are more swaps which are required in certain cases, right? So that shows an indication, like if you have to swap everything, that's an indication of bad performance, for example. The time complexity is always defined based on the worst case scenario. Yeah, okay, cool. So I think everyone understood the concept. The answer is B, because in B is when you have the maximum swaps and when you have the maximum time, worst case scenario for ascending order. Okay, does everyone understand this? I don't know why some of you answered unique elements. Unique elements or not unique does not have much to do with the sorting process itself. Of course, if two elements are the same, that can, that doesn't really matter. But descending order matters because you have to essentially change the entire array around, but you do it element by element. So it takes more time than more swaps than usual. Does everyone understand? Is there any doubts? I don't think there are any doubts, so we can go to the next question. How many passes does bubble sort make through the array? So not swaps. Okay, how many passes does it make through the array in the worst case scenario of sorting n elements? Please put your answers in the chat. Okay, one person says n, a, another person says a. Okay, one person says b, one person says d. One more b in the chat. People seem to be, yeah, I can see A, B, and D. Okay, one more D in the chat. Okay, I'll give one more minute because there is variety of answers in this case. B. Okay, I don't see any other answers. The answer is actually B. Okay, if you go through it, you make it through it first n times, the element bubbles up to the top, then again you go through the second largest element bubbles through all the swaps to the top, then the third pass, the third biggest element bubbles through all the swaps to the top. But for the last element, the array will only have one element, right? There is no need to go through the entire array at that point, so it will be n minus 1. Does that make sense? So I can show you again with this example, or I can show you the program. That will be better. So suppose my array is in the worst case scenario, right? 23, 10, 2, 1. So let's try to understand. Of course, if I run the code, it will work. But let's try to understand what's happening, right? So my length of my array is 4. Now I'm going to go through the array n minus 1 times, right? Because range n. So the first time it goes through, you can see that it goes through the entire array and it has to swap. Then second time, third time. So it doesn't have to go the last time because it'll just be one element. It's not really going through the array. That is the point. Does everyone understand? Is there any doubts? Any doubts in this? Sorry, I'm in the wrong slide. Yeah. Any doubts in this? Okay, no. Great. Okay. So this is the idea. N squared is wrong, obviously. N is also wrong because the last point it's not really going. You don't have to do in the last part, right? Okay, now we are going to go through another longish question. So let me just read it out to you first and then we can see what the question is. Okay, please stop me if you have any doubts. So this is about something which I didn't discuss but which you already saw in the classes, which is binary search. So whenever you have a binary search, you usually have an array which is sorted in ascending order, and then your goal is to try to find out where a certain element is there or not, right? So you initialize pointers or basically two indices, or not two indices, that's the wrong word, two values, low and high, which points to the start and the end of the array respectively. You calculate what is the midpoint of the array and compare the element of the midpoint with the element that you're searching for, right? So if you find the element to be the midpoint, then good for you, you can just find that. If the midpoint is less, then you just try to look in the second half of the array, because the midpoint is less means second half should have your element, right? Because it's already sorted in ascending order. So one very important thing about binary search is we have to use a sorted array. That's why we know that we can compare with the midpoint and confidently say that if midpoint is smaller, then my array element is in the second half. Otherwise, if the midpoint is higher, then the array element is in the left half. And then you keep on doing this. You keep basically cutting the array into two parts until you find the actual element that you are searching for. So this is the uh, basically your binary search algorithm. Does anyone have any doubts in binary search algorithm as such? I didn't write the program for it. I was more focused on sorting, but if anyone has any doubts, you can ask now. Essentially, what you're doing is it's called binary because you keep dividing the array into two parts and comparing the element with the mid of each part. So first you isolate which half the array is, then in this array, which half of this array, then in this half of a half, which half. Like that, you have to keep on comparing. Any doubts? Okay, if there are no doubts in this, I can go to the question. So the question is, which steps would require modification if the array was sorted in the descending order? Is it step 2, step 4, step 2 and 4, or there is no modification in the steps? So I'll again show you the steps so that you can understand which it is. Any answers in the chat? This is the question. Which steps is require modification if instead of ascending order, we have a descending order array and we want to search in that? Okay, I see two people are saying D, no modification. Others also please answer. Okay, someone says is modification needed in third step or first step? D. Okay, I think we can go to the answer. The answer is actually step 2 and 4. Huh, it should be step 3, right? I don't know why. Give me a second, I'll just check this. It should be step 3. I didn't notice this while preparing the questions. Give me a second. Yeah, it should be step 3. I think the option is given wrongly in the old pro thing. Let me just change the answer to step 3. So, yeah, why is it step 3? Does anyone want to explain? I'm really sorry. I was copying the problems from last year and the solutions. I somehow didn't check. I thought step 2 and 4 is like, I thought step 2 is this one. I made some mistake while making the slides. I'm really sorry. But now I've corrected it. Does anyone want to explain why step 3 has to be modified? Or how it should be modified? Yeah, research sites will change. Exactly. So when it's in descending order, if it is larger, that means that actually it's in the first, sorry, okay. Let's see. If it's in descending order and my element is larger than the midpoint, that means it's in the first half, right? Not the second half. Now it will be the opposite. Also, in the first step, if we change low with high, it will get reversed. Yeah, exactly. So if you call low high and high low, that also works. But we call low as, yeah, correct. So instead of changing that, we can call high as the first element because that is the highest value. That can also work. So either the third step or the first step. If you mean low to mean the lowest index as in 0, then you don't have to change it. But if you are interpreting it as the lowest value, that will be the last value. So you can also swap it like that. So very good. You guys are finding out problems or mistakes that I may have overlooked when I was quickly making the slides. Again, very sorry about that. I kind of overlooked this when I was making the slides. Okay, so these are again, these are the last year's questions that I'm trying to solve for you. So maybe some errors were there which were overlooked at that point, or I might have made some error while making it. But very good that you guys are able to. Yeah. So we can change this to say step 3 or step 1. So again, try writing algorithms for the descending order of everything we've discussed. So there are 4 programs that you have to try to write, which is bubble sort, selection sort, insertion sort, all with descending order, and finally binary search. And when I say write the program, I don't mean copy the bubble sort program I gave you and change the greater sign to less sign or something like that. I mean that sit down and try to write it from scratch. Then you will get an idea about how the algorithm actually works. Okay. So that will be a very good practice for you to understand these things. Okay, now finally, I think this is the last question. Select the correct statements among the following. So this is MSQ, which means there are multiple answers which could be correct. Okay, so these are all about binary search. Please select which are the correct options among this. Screen not visible. Oh, okay. I'm so sorry. I stopped sharing and I didn't share again. Can you all see now? Thanks for pointing that out. Yeah, I just had changed this to step 3 or step 1 because of our discussion. And now I'm showing this is the question. So this is all questions about binary search. Please answer which are the correct statements. There could be multiple correct statements in this case. Can you all see?
No, screen is gone.
Oh, okay. Okay, give me a second. I don't know why, what happened. Maybe I pressed it by mistake. Okay. Okay, can you see now? Yeah, okay, great. Answers in the chat, please. B and C. Others? B and C. B and C. Okay, I think we can move on because we have to do the programs also. But yeah, very good. All of you found the correct answers. Binary search may or may not find the first occurrence of the element in the list. Suppose there are 2 elements and one of them is in the middle and one was just before the middle. Then when binary search finds the middle element itself, it will stop. It will not find the duplicate which was before that or after that, right? Whereas in the presence of duplicate elements, the binary search algorithm with minor modifications can be used to also find the first occurrence of the target element. So the existing one will find may or may not find, but if you kind of modify it to just do one more search so that it can find out, then you can also like just check the element which is just before and just after, then you can also find the duplicate element or the first occurrence also, right? So this is something that you can do. So very good. So now, oh God, okay, one sec. 1 second, I think I mixed up the answer and question slides. Okay, give me a second. Um, God, I don't know why so many mistakes today. Sorry, guys. Uh, okay, let me share my screen again. Yeah, so you can see my screen, right? So, yeah, swapping of two elements is an intermediary step in any sorting algorithm. In the lecture, we use a temporary variable, but can we do swapping without using a temporary variable? Please answer in the chat, answer quickly so we can move to the programs of today. I think we are already quite behind time. Okay, good. Immediately people are saying A. So, yeah. Okay, great. So, yeah, the answer is actually A. The answer is yes. So, as I said before, like I already showed you one way in which you can swap because of Python's flexibility. You can just write array of I, array of j is equal to array of j, array of I, and it works. But you can also do it without doing that also. There's another way to do it. And I had shown you that or I had included, I don't know if I had time to show you, that was in the week 2 lectures. So please go back and try to look at the week 2 lectures and you can find various ways in which you can swap. I think I have included one or two methods in which you can swap elements in an array. So in the week 2 programs, you can find swapping and how that is done. Okay, so very good. All of you answered correctly. So now let's do some programming. So I'll again, as usual, I'll show you the program statement. I'll give you some time to at least try the solution because as I always say, until you try programming, it's not going to work for you. After that, I'll show you the solution and we can discuss. So I have 4 questions today. Let's try to do at least 2 or 3 of them. Okay. So this is the first question. Write a function which accepts a sorted list L of integers and an integer x as input. The function should return a sorted list with the element x inserted at the right place in the input list. The original list should not be disturbed in the process. And you are only allowed to use append and remove. You should not use any other thing, and you don't have to accept any input. You just have to write the function definition. So this is again from last year. That's why they have talked about console and stuff. So this is one of the assignment questions of last year. So does everyone understand the question? Why don't you try doing it? I'll give you maybe 10 minutes, 10-15 minutes I can give you to try doing the program, and then I'll show you the solution. Okay. Any questions? You have to basically, you have a sorted list of elements. I give you an element and I'm saying that insert it at the correct position. So suppose I have 1, 2, 4, 5 and you have x as 3, then I should insert 3 at the correct position. So finally the list is 1, 2, 3, 4, 5. This is the idea. Any doubts or questions at this point? I don't think so. So you guys please try it out and I'll show you the question. I mean, I'll show you the answer after 10 minutes. Okay. I'll show maybe at 7:30 we can look at the answer. I hope you guys are trying and if you face any issues, please tell me, or if you don't understand the question, please let me know. Okay, how many of you are trying the program? Please raise your hand. Okay, good. Please, 1%. Yeah, okay, good. People are trying. So I'll give you some time more. Please keep trying. I just wanted to know that you guys are actually trying the program. Okay, I'll give you 5 more minutes, or even more time if you want to try, and then we can discuss the solution. Mind blank. Okay. It's the end of the day. Maybe that's why. But yeah, we can uh, I'll show you the solution in couple of minutes. Then hopefully you will get how to do it. So others, are you also in mind blank state? Yeah, okay. One person has their hand raised. I don't know for mind blank or something else. Okay, let it be 7:30. Then I'll show you the solution. Okay, shall I go to the solution, or are you guys still trying or something? People, are you still trying? Shall I go to the solution? Any response? Are you still there, or have you all left with my blank mind? Okay, I guess I'll go to the solution. If anyone is still trying, then yeah, you can continue to try, but I'll just show the solution for interest of time. Uh, Wait, sorry. Solution, please. Okay, great. So this is program 1. Okay, so this is basically the program. Let's go through it one by one. Still there with blank mind. Okay, good. Uh, Fine. So, right. So I'm just seeing the chat on my phone also on the side. So essentially here you're defining this function insert, which takes in the L, which is your list. If you remember the question, L is your sorted list, and X is basically your this thing, right? X is your input, right? So we have out of L, which we are defining as an empty list for now, and inserted, which is just a flag to know whether the element is actually inserted or not, to be false. So this is basically your, just to make it clear, this is your output list, and this is a flag. So now for the element in L, so it goes through every element in L, and if not inserted, which means if inserted is still false and the element is greater than X, so again element is this one, then append X to the output and inserted is true. Okay. Otherwise, you're just going to append the element. So basically, it only appends the X if it is less than the element. Otherwise, it keeps on appending the elements, right? If any bigger, if any smaller than X element comes, then it will insert all of them. And the moment it inserts X, then inserted becomes true. So it will not go through. So it will not just keep on inserting X, right? It will, once X is inserted into the output element, inserted becomes true. So very important is X is inserted only once. This if condition only runs once. Okay. If after going through all the things X is not inserted, what does that mean? That means that X is bigger than every element in the list. That is like if I give you a list like 1, 2, 3, 4 and I tell you to insert 5, you have to insert 5 at the end, right? So after everything only you should insert. So this is when X is bigger than all other elements. Okay. So then you return the output, then get L as input. You're basically getting it as a input list. So enter as and then you're changing it to a number, you're getting X. And then you're just basically inserting and printing. So if I now just, okay, wait one second. 1, 2, 4, 5 and enter X as 3, then I get 1, 2, 3, 4, 5. The program. I can show you again another example. Suppose I have 144, 67. It should be in a sorted order. Okay, that is the main thing in the list. Suppose I have this. Oh, sorry. I'm so stupid. One sec. Huh. So if I enter 144, 56, 89, 102, and then I enter X to be 23, you can see that it is inserted at the correct position. Okay, so basically what you're doing is you have to you are basically going through all the elements, and then you are just checking this flag. So the moment the flag becomes true, then we know that x is inserted. I don't need to worry about x anymore. I can just output, I can just append all the elements. So this is the idea. Okay, does everyone understand the program? Is there any doubts in the program or the logic or something? This is basically like you're sorting or you're searching, right? You're checking each element. The only thing is now you have to just insert an element. Instead of searching and retrieving an element, we have to insert an element. So again, you have to go through the whole array and then you have to insert the element. That is the point. And they told us not to mess with the original array. That's why it is done in terms of a new array. Does everyone understand the program? Any doubts? Any doubts, anyone? It's not a very complicated program, right? Do you guys agree? Is it fine? The main step is to figure out that we needed this flag so that we know that when x is inserted, I don't have to worry about x anymore. Other than that, you're just writing all the elements from one array to the other array. Of course, there are many other ways in which you could do this as well, but this is the way in which this has been done.
I have one query.
Yeah, sure.
Like, so you are making this like I can't see the code.
Yeah,
Can
yeah,
you
sure. Tell
remove
me.
this? Yeah. So you made inserted as a false. So the
Mm-hmm.
flag was false. Then
Mm-hmm.
a not inserted is the reverse of it.
No, no,
Like
no.
it's true. It means if inserted is true.
No, no, no. So it if not inserted means if it is false, that is what it means.
Okay, so not inserted. Inserted was false, so not inserted is also false.
No, no. If not inserted means it's checking if inserted is false or not. That's what it's checking. Okay,
Okay.
okay, okay, okay. I understand what you're saying. So, no, what I said is kind of wrong. So when does a if condition, when do you go into an if condition? When something is true,
When
right?
we want to check, when we want to
No,
check
no,
a
no.
condition.
Yeah, yeah, that's true. So if I give if some condition, if that condition is true only, it will go inside a loop, right? Correct?
Yes.
You agree?
Yeah.
So if I have here if
Yes.
inserted, this condition is going to be false. It will not go into the loop. Correct?
Yeah.
So that's why I have to give not inserted. You're right. Not inserted is true. But why not inserted? Because then that means that it's still true. I mean, not inserted is true. I know it sounds very weird, so let me just say it again. Not inserted is true, which means it's not inserted. Okay, so that's why it goes to the loop. The moment it becomes true, the moment inserted value becomes true, then what happens? This condition is false. It will not go into the loop. That's what we want. If inserted is already true, if it goes into this loop, then again and again x will get inserted, right? It'll keep on, it'll be like 1, 23, 23, 23, 23. We don't want that to happen. We want the element to be inserted only once. So what happens the moment this becomes true? The moment this becomes true, if I go to not inserted, now this is false. If this is false, it will not check this condition. Do you understand?
Okay.
Okay,
Yes.
great. We can also
I
do it
I
in a
was confused. I was confused. Like inserted should be equal to true, and then if not inserted, shouldn't it be that way?
it can also you can also do it. So suppose we make it as not inserted is true. Okay.
No,
Then
no.
this
Inserted. Okay. Okay. Yeah,
I
understood.
mean, if the reason I'm making not inserted true is the inserted means that the element is inserted. That's what we are trying to do, right? Do you understand?
Okay.
So that's why not inserted, this
Yes.
confusion is there. But if that is confusing to you, then we can also do the program. I'll just write it as a comment so that both of them are there. So then this condition can just be not inserted. This will be also not inserted. So let's try and see if that is still working, right? So let me just comment out this and uncomment this. So this is the same program. Instead of having inserted as my variable, I'm having not inserted as my variable. Okay. So let me make this not inserted is, oh, okay. I have to change this also actually. Otherwise I'll get an infinite loop. So let's make this not inserted is false. Okay, this should work. Hopefully, I think this should work. Let's see. Okay, enter the value. Hopefully, it doesn't give us a infinite loop. 1, 2, 4, 5, 3. Yeah, it works. So yeah, it's just a matter of how do you want to flag it? Do you want to flag it as when it becomes inserted, it's true? Basically, we want the program to be that when it is inserted, it's true. If I give inserted as true and then change to false, the program will still work, but it might be confusing for someone to understand, right? After the element is in now I forgot how to say the word inserted, if the value becomes false, that may be confusing for someone, right? So that's why I made it into this way. Okay, is it fine?
Yes, thank you.
Okay, cool. So I'm going to, when I share the program, I'll share it with these comments also. This is just another way to do same thing. Okay, don't get confused. We don't need two if statements. Yeah. Okay. So this is basically to ensure X is inserted only once. The idea of the program is the same. I mean, I don't even have to call this inserted. I can call this some A, B, C, D, E also. The reason why to choose variable names, as I keep saying, is that tomorrow or 6 months later, when you take this program, if the variable names are A, B, C, D, E, F, G, it might be difficult for you to understand. Whereas this program, if I take after a few months also, I'll understand immediately. Inserted tells me whether the element is inserted or not not insert or vice versa, right? If I use not inserted. So yeah, if false true is confusing, you can do it in some other way also. As I said before, you are completely free to do whatever you want as long as you understand the logic and it works. Great. Okay, we can go to the next question. So this is the next question. Accept a sequence of words as input. So like a sentence or something. Create a dictionary named Real Dict, whose keys are the letters of the English alphabet, and for each key, you should get the corresponding value should be a list of words that begin with this letter. Okay, so you have to append it to the sequence basically. And if you can, if for example, if I have a sentence that is like, let's say, my name is Nitin, suppose, then my N will have name and Nitin, and I will have is. So M, N, and I becomes the keys, and values will be my name, all the different words. Do you understand the program? I think program is understood by people. Please give it a try. I'll give you 10 minutes or so. Any doubt? Someone having a doubt? I hope you understood, right? You accept some sequence of words as input and create a dictionary to basically have each word. So here it's actually like a dictionary, like what we call dictionary in real life, where you have different letters and the words corresponding to them. So you're going to be creating a dictionary using Python's dictionary. So yeah, please try it out. I can give you 10 minutes. I have two more programs, but I don't know if we'll have time. As usual, all the programs will be shared with you in the chat. Sorry, not in the chat, in the drive, Google Drive. So if you have any questions, you can always approach me over mail also later.
Where in Google Drive are the programs shared?
I'll show you off. Okay, maybe I can show you immediately. So, you guys have this Google Drive, right? Where is this? You have the Google Drive link. If you go to week 2, for example, you can see these are all the programs. 1, 2, 3, 4, 5 programs are there.
Can you reshare the link of the Google Drive in chat?
Yeah, I'll share it at the end of the class. Okay. So basically, I'll share you the link for my website. So if you go to the website, this is the YouTube playlist where all the videos are there. This is also the Google Drive. Okay, I'll share it now. I was just thinking then. Here. So in this page, the YouTube sessions and the Google Drive both are there. So you can always quickly refer. I think the NPTEL team is also sharing with you, right? Every week. They should be sharing with you the links to everything. So you can also find. I just made this website for easy reference. Anyway, this is the program. I'll give you 10 minutes. Please try it out. I hope you guys are trying. I know it's like towards the end of the session. Just try this and then we can, maybe try to do one more program and then we'll close. Are you guys trying? Any luck? Or should any doubts or how many of you are trying? Yeah, okay, good. I'll give you a couple more minutes maybe and then show the answer. Okay, maybe we'll go to the solution because class time, I don't want to keep you guys more than class time. So I'll show you the solution. As always, please try it also. Keep trying if you're doing it right now. It's always good to try and get the solution on your own. Okay, so let me just go. Right, so this is basically the list of words. So here I've taken it as comma. So it's, but you can also take it as space. So here you are defining a dictionary, and for word in L, which is your different words, you are going to take start as the starting of the word, right? Which is the zero the position of the array, which gives you the first letter. So for example, if I have yeah, so like the first letter, if I want to take, it will be the zeroth part of the array, right? So that's exactly what I've done here. So if start is not in real dict, like if that starting letter is already not there in the dictionary, then keep it, have it as part of the dictionary, and then append whichever word is already starting with that letter, and that's it. That's all you need to do. So it just keeps appending to the start, and if it is not there, it just starts a new key value for it. Okay, so this is how you basically start a key value. So if I now run this program, oh, sorry, I'm still in Python here. That's why. Clear. Okay, so if I run this program now, hello, hat, cat, Python, class. You can see that H has hello and hat, C has cat and class, P has Python. Real dict is equal to, yeah, that should also work. Let's try it out. Hello, hat, cat, Python, class. Yeah, that also works. So you can initialize the dictionary however you want, either using the curly braces or you can initialize it like this also. So always remember, there is so many ways to do everything in Python, right? So there is no correct or wrong way. So yeah, to answer your question, that also works. I just ran it and checked and it is the same thing. Okay, does anyone have any doubts in this particular question? Any doubts? Any doubts at all? I hope you understand. We are just going through the words, taking the first letter and adding it to the dictionary. And then appending all the words to the dictionary. That's it. Any doubts in this process? So for this, you really need to know what is dictionary and how to call the elements of a dictionary. It's basically testing that. Okay, I don't see any doubts. Let me just quickly show you the question and I'll show you the program also. But again, please try to do all these questions on your own. That's why I make I do make the programs available and the slides available also. But the correct way in which I would say to approach this is to look at the slides, try the program first. If you're stuck somewhere or if you want to get the hint, then look at the solution. But always try to do it on your own first. So the next program is this, which is write a Python script to generate and print a dictionary that contains number 1 and n. Between 1 and n contains numbers. Sorry, not a number. Numbers between 1 and n in the form x, comma, x power x. Accept n as the user input. So here basically you are taking n as the user input and you get x power x for every n. Okay, so you have key values as key values to be 1 to n, and the key, sorry, key value I'm saying, keys to be 1 to n and values to be x to the power x. So again, I'm showing you the solution because we are almost at the end of the class. So maybe I can just show you the solution for this. But basically, you are prompting user to enter a number, store it in the variable. You're creating empty dictionary. You can also create it using your curly braces. then iterating through the numbers, you can see that n plus 1 is used because if you give range, it always cuts out the last number. So that's why you have to give n plus 1. So n is also included. And then the dictionary is basically x to the power x. Why is it x into x? Sorry, x power x. And print the dictionary. Right? So let's try running this. So enter, for example, 4. Then it gives me 1 power 1, which is 1, 2 square, which is 4, 3 cube, which is 27, 4 to the power of 4, which is 256. It was x power x, right? Oh, sorry, it is x into x. It's x square. I don't know why I thought it's x power x. Let me just write it as x square. I got confused, guys. Sorry. X square. Okay. So yeah, let me just run it again. So if I input, for example, 9, then you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, and there are various squares. So this is how you do this program. Is there any questions in this? This is also a very simple program. So I wanted to discuss it before the class is over. But here again, this program and this program are kind of similar in that you're just, this is more of exercise in how to call a dictionary, how to initialize a dictionary, and so on. Okay. Okay. Okay, I think that's it. The last program is a little longish program. This was from last year's NPTEL assignment. It looks very long, but it's a simple program only. It's basically you have to calculate what are the different kinds of moves you can make on this sort of board given all these rules. So I have the answer is there in the week 4 program 4. I'll do one thing, I'll share it with you guys. If you have any doubt, please mail me, and maybe we can close the session for now because I think it's already time. So yeah, just to remind you guys, this is my email ID, and you can, I'm always reachable on my email ID rather than the discussion. I mean, I check the discussion forum sometimes, but there you have questions which are for the instructor also. So if you want personalized questions, you can, it's better to mail me. I'm usually active and will respond to you pretty quickly. And if there is some particular programs or particular topics you want to see covered in next week's class or any of the classes, please mail me a few days in before the class happens. So if it's on Monday, can mail me on Friday or Thursday, by Friday or Thursday, and I can include those things in my lecture. So basically, because this is an interactive session, you can basically ask me to cover certain topics or focus on certain topics. So in the absence of that, I prepare the lecture with some topics which I find interesting or I find relevant. But if you guys agree that some particular topic that was in the class that you want to be covered again, I can do that also. I already shared the link to all the videos and everything. I'll share it again. If any doubts, or I mean, if you have any problems in the week, as I said, please mail me. Okay, and please try the programs, all the programs. As I mentioned before, I do share all the programs in the Google Drive. So please take the opportunity to also share the try the programs as well. Okay, I think that's it for today. We can close this session. I didn't want to go to the last program because it's a longish program, and I mean longish to understand, and I don't want to go too much ahead of time, which you have. So please try it out. It's just a big problem statement, but the implementation is not very difficult. So please try it out. And if there's no more doubts, we can close the session. Any final questions, comments, queries, anything? Okay, I don't think so. Then fine, guys. I'll see you next week, same time. Have a nice week. Bye, everyone. Okay, stop the recording.